So we previously did these problems, and this is where we stopped. So I just kind of rewrote it, so it should be close to what I had before. If an element is moved around a little bit, it's still the same Lewis structure. Remember, they can move a little. All right, so for CO2, we had the choice, right? We were here. Carbon only had 6 electrons. Okay, so we only had 6 electrons. We wanted to give him 8. So our choice was to either move here to make a triple bond, or our choice was to move here to make a double bond. And I said in that lecture that this one was better because it was symmetric. But we want to make sure, and we want to prove it. The way that we prove it is through formal charge. So just like we did before, we're going to do the formal charge. Now we do it with one double bond because we knew we were going to do at least one, okay? So we go ahead and we do it before we have our choice, before we do the move. So we're going to do it for the left oxygen and for the right oxygen, okay? So how many valence does oxygen have? 6. Okay. For the left oxygen, how many electrons? 1, 2, 3, 4. How many bonds? 1, 2. So he's got a 0 formal charge. This oxygen is 6 valence. How many is on him? 1, 2, 3, 4, 5, 6. How many bonds? 1. So he has a -1. So since he right now has a 0 formal charge, that means we don't want to do this. He has a -1 formal charge, so he says, please take some electrons. So when I took some electrons, I moved him. Now he has a 0 formal charge because he has 6 minus 1, 2, 3, 4, 5, 6. So that's why we picked this guy over this, because of that formal charge, okay? Because we don't want to mess with somebody who has 0. If he has a 0 formal charge, he's stable. Now our next question, can carbon have more electrons? We go here and we look. Carbon is in row 2. So that means, nope, he can only have 8. He can't expand. So that means this is our final answer. We are done. All right, let's go here. Let's look at SeOF2. Okay? We didn't have to make any double bonds to make him happy. He already has 8 because we had all the electrons already on him. So our next question isn't necessarily, do we need which choice I had? So when we were drawing him, we didn't have choices. To make a double bond. So we go, okay, he's happy. So the next question would be, can he have more than 8? So let's look. We come here and we say, ooh, he's all the way down here in row 4. So that means he can have an expanded octet. Okay? So he can, Se can expand. So the next question we want to know is, will he expand? Is Se going to want to have more electrons than what he currently does? So how we figure that out is we want to go ahead and draw the expanded octet. So the way that we draw the expanded octet is that we have to do the formal charge. So in this case, we have to do it on every single element that has an electron and the guy that is going to expand. So we have to look at the expanded guy and all the other elements. So let's do the electrons. Whoops. Oh, there we go. Se has 6, oxygen has 6, fluorine has 7. So now we know the valence. Se has 6, oxygen has 6, and Fe has 7. So we did the valence. All right, how many electrons are sitting on Se? 2. How many bonds? 1, 2, 3. So he has a +1 formal charge. Let's look at the oxygen. He has 1, 2, 3, 4, 5, 6 sitting on him. And 1 bond. So he has a -1. Fluorine. Both fluorines are the same, so we don't have to do it twice. He has 1, 2, 3, 4, 5, 6 sitting on him. Okay? And then 1 bond. So that means he has a 0 formal charge. So now we have to say, well, what does that mean? So if he has a 0, that means don't mess with him. Leave him alone. Se has a +1. So that means he would like 1 double bond. He would like you to move 1 pair. Oxygen has a -1. He would like to move one pair. So that means that if he's a plus and he's a minus, he's going to expand, and the way he expands is it's going to come from the minus. So it always goes from the minus to the plus. So it's going to go from the guy who's the minus towards the plus to make a double bond because he wants to expand. So let's see what that looks like. F's don't change. I mean, the F's don't change, sorry. Se keeps those electrons, but what happens is now we have a double bond. So this oxygen moved those electrons here to make the double bond. He still has 8. 1, 2, 3, 4, 5, 6, 7, 8. Now the Se has 2, 4, 6, 8, 10, but he could expand. Now you might say, well, can I expand more? Well, if you wanted to know, you would say, what's the formal charge of oxygen? 6 minus 1, 2, 3, 4, 5, 6. He's at a 0. And the Se now is at 1, 2, 3, 4, 5, 6. He's at a 0. Everyone's at 0, so they're completely happy, so we are done. So that is the completely happy, done picture. All right, let's do NO2. So this is where we stopped with NO2. We had to make a double bond, but both of the choices originally were the same. So N is happy. He's got all 8. I didn't have to use formal charge to decide if he was going to be happy or not. But I have to say, can he be happier? So I go and I look and I say, can he be happier? He's in row 2. Nope, he can't be happier, so I am done with him. All right, so he is now completely done. On the next video, we're going to do the other 3 problems that are on the next slide.